Wire of a certain material is stretched slowly by 10%. Its new resistance and specific resistance become respectively A 1.1 times, 1.1 times, B 1.2 times, 1.1 times, C 1.21 times, same, and D both remain the same. So now to solve this, we need to know the formula R equal to rho L by A. Since we are stretching the wire, so if the wire is this initially, if you are stretching it, its area of cross section decreases, but the volume still remains the same. So we need this formula in terms of volume. So in order to get volume from area, we just have to multiply length, and now we get rho L square by area into length, which is volume. Now to get the relation, we know that volume is constant, rho is also constant. So we have the relation R proportional to L square. We are given that length is increased by 10%. So our new length L2 will be equal to L1 plus 10%, 10 by 100 of L1, which is equal to 1.1 L1. Now with this relation, we can find how the new resistance changed according to the initial resistance. So we have R2 by R1 equal to L2 square by L1 square. Since R is proportional to L square, we know L2 we've got it as 1.1 L1, so 1.1 L1 by L1 whole square. We can cancel them and get 1.1 square, which is 1.21. So we have R2 equal to 1.21 R1. So the new resistance has become 1.21 times of the old resistance. So we have 1.21 times the new resistance value increased. We also asked how much the specific resistance also increased. Since specific resistance depends upon the material, here since the material is not changing, only the length is changing, we can tell that it remains the same. So our answer is C, 1.21 times, same.